Hello, students. In our previous class, we started the discussion of operating system, the function of operating system, where we just left this topic, memory management. So today we'll start from here. What is memory management? Actually, memory are of two types, secondary memory, primary memory. But if somewhere only memory is written, if primary memory is not written or secondary memory, then memory simply represents primary memory, the RAM. Okay. So here memory management simply means how the RAM is managed. Now, what is the utility of RAM? You already know, but let me tell you, RAM is also known as the primary memory because primarily everything is loaded in RAM and then it is executed. Means whatever thing need to be executed, whatever things need to be worked on with, uh, all those things are loaded into RAM. From where they get loaded? They get loaded from any external device like input device. The programs in RAM get loaded from secondary devices like hard disk or CDs, pen drives, or any other secondary device. So it gets loaded into RAM and then it starts executing and then we work. So memory management simply means how the RAMs are managed. So let us try to understand this in our class because we are learning operating system, and generally most of people know what is operating system and thus they are happy with that. But you need to know the technical things in related to operating system. Means what are the functions of operating system, how it manages the things. You already know that operating system manage everything. You have learned it. You have been listening these things from very beginning. Now, what things are there? So these things are there. So in a computer, both the CPU and the input-output devices interact with memory. As I said, that RAM with RAM, input-output devices are already connected, and processor is connected. The data goes to processor from RAM, and after getting processed, it comes back to the RAM, and then it goes to the output device. Or if you are inputting something, then from input device also it comes to the RAM. Is the junction with which everything is connected. So when a program need to be executed, it is loaded onto the main memory. Main memory means the same RAM till the execution is completed. As long as the execution is going on, that gets loaded into the RAM. Okay. Now what? Thereafter, that memory space is freed and is available for the other program. Suppose if you want to run any program like Paintbrush or MS Word or Excel or any other program, when you double click it, then it get loaded from secondary memory to the primary memory. Let us see this. Let us see this. Like if I want to open Paint program, this is painting, then it takes some time, although the system is fast, so it get loaded, and it's a small program, so it doesn't take much time in getting loaded. Now whatever we are doing, like I'm doing this, so these things are happening inside RAM. These things are getting stored inside RAM, and when we close it, then it asks, do you want to save it? And when we save it, then it gets saved to the secondary memory. There also, the secondary handling secondary memory is also the task of or file managing. If you save this thing, then a file will be generated, okay, or created. That file management is also the task of operating system, which we will see now. And if you don't save it, then what will happen? It will not be saved, and this program will be closed. And the space which this program was taking in RAM is freed and can be utilized for the other program that will start. Now let us try to start any other program like MS Word. So look, it is taking little bit more time than Paint. Why? Because it is a bigger program. It takes more time to get loaded from hard disk to RAM. And everything depends on the resources that is available. I mean, if you have fast processor, if you have enough RAM, if you have good hard disk, then things will work fast. In my system, I have SSD hard disk, 8 GB of RAM, and I have i7 processor. So it's a good machine. It's working fast. So this is how this thing is happening. And If you'll again close it, it asks the same way. If you'll save it, then a file will be created and will be saved in the secondary memory. If you don't save it, then it will be cleared from RAM. Look, if we want to see what things, means the basic things are there in your system, then you can press window button and the pause break button is there in your keyboard. Pause or break button is there in the keyboard. With the window button, if you press this, then you will see the system's property, and in front of you, you can see what processor is there. Intel i7 7th generation processor is there. Then RAM is 8 GB of RAM, and what type of operating system is 64-bit operating system is there in this system. The same way you can find what is the configuration of your system. Okay, so this is the work of memory management. This is how the operating system manages the RAM. So the common memory management techniques used by operating system are partitioning and virtual memory. So दो तरीके से ये handle करता है generally. This is not a small topic. This is a large topic. If you see in detail, it has a lot of things to learn. But let us lightly see what these things are. So first thing is partitioning. What is that? The total memory, the total memory here means RAM. Okay, the total memory is divided into various partition of same size or of different sizes. The RAM is divided into the partition of, like, if you have a large hall or large space, then we can make a lot of rooms of same size or different sizes. Okay, so the same thing is there. This helps to accommodate number of programs in the memory. If you have created rooms in a given large space, then in one room we can keep something else, we can keep another thing in another room, like this. So this is how the memory is managed. The partition can be fixed, that is remain same for the all program in the memory, or can be variable in them. The memory is allocated when program is loaded into memory. So we can perform multiple tasks, multitasking we can do. So for various programs, space is needed, then only it can execute. So for keeping those things in the memory, we need a space, and this is how the space is managed. So memory is allocated when the program is loaded into the memory. The latter approach causes less wastage of memory. I mean, if if the memory is partitioned in equal length, equal size, then maybe a small program is there which doesn't need that much space. So even though it doesn't need that much space, and if the memory is partitioned in equal size, then there it causes the wastage of memory. But in the latter type, I mean, where we variable memory is there, variable length memory is there according to the requirement of the program, the memory is space is allocated. So that's why this statement is written. The latter approach causes less wastage. If your variable uh, is length is there, partition is there, then it causes less wastage. You can easily understand. But in due course of time, it may become fragmented. Fragmented means getting divided into different sizes, fragmented. Then defragment is operated. Defragment is a kind of one of the operation of operating system which manages the memory, which defragments it. Fragmenting means breaking up into small pieces, fragmented, and defragmented means to again fragmenting in one part. So this is happens. Another concept is virtual memory. You need to know about this also as you are learning operating system. So these things are important. This is a technique used by the operating systems which allows the user can load the program which are larger than main memory. Now the thing is, what will happen if we are trying to run a program, or if you're trying to run multiple programs which need more space than is available in your system? Like if you have only 1 GB of RAM available, or only 2 GB of RAM available, or even 4 GB of RAM available, or even 8 GB, but still if it is not enough for the programs that you want to run, then what will happen? So here comes the concept of virtual memory. This is a technique used by operating system which allow user can load the program which are larger than the main memory. In this technique, program executive, even the complete program cannot be loaded. So, although not much is written here, but let me tell you, virtual memory uses what? It uses some space of hard disk available. Hard disk is large memory, so some space of hard disk is reserved as a virtual memory. And suppose if you want to run a program, and if there is not enough space in RAM, then what happens? Some programs which are already there in RAM, which are not in use right now, they are shifted or swapped to the virtual memory, which is a part of hard disk, and then the space is freed for new program to get loaded in that freed space, and this is how this works. Although, since hard disk is not as fast as the RAM, so overall process get little slowed down, but still the program doesn't stop working. It will still work. Maybe a little slowness may come, but so what is virtual memory? It's a part of hard disk which is used as virtual memory. In case if your available main memory is not enough, then these things happen. If you have already enough RAM, then it's okay. Now another thing which is done by the operating system, and this is one of the most important thing, use as the user point of view, if you'll see files or file management. Whatever we do in the system, then we save it. The data is important for us, and whenever we save anything, no, a file is created. So files are important for us, and those files are managed by the operating system. Yes. So you know already this, but let us see this. The operating system manages the files, the folders, directory system on the computer. Any data on a computer is stored in the form of files, and the operating system keep information about all of them using file allocation table. File allocation table is something where all the details of all the files which you are storing in the hard disk is stored. So this also is managed by the operating system. So any file you are making, any folder you are creating, or anything that you are doing is managed using this file management part of the operating system. One of the important point is here, which is discussed here, is FAT, file allocation table. Now, what is FAT? Although FAT is a topic which need time to discuss, but in shorter way, I can explain it and try to understand. File allocation table is something, a kind of register where we keep records of things, that kind of thing. And in this table, every detail related to a file is stored. Now, let me give you one example to understand how FAT works, a file allocation table works. Suppose there is a large colony. Thousands of houses are there in that colony, and people are living there. So how can we come to know that in which house who is living? So there is a so if a lot of people are residing there in that colony, thousands of houses are there. Then how can we know that who is living in which house? So there could be a register. If you're working manually, then also there could be a book, a register, where every detail is written. Yes, this is section A of a colony, section A, B, north section, the south section, kind of this thing. So in this section, 10 houses are there. House number one, house number two, house number three. In house number one, Mr. X is living. House number two, Mr. Y is living. Like this, a register is maintained which keep record of who is living where. Almost same way, the file allocation table also keep record of every file that is getting stored in the hard disk or any secondary device. Not only about hard disk, any secondary storage, hard disk, CD, pen drive, memory card, or tape, or anything, any secondary device. So this is one of the part of operating system which keep a record of files where they are stored. I mean, let us see what is. The FAT stores general information about file like the name of file, type of file, whether it is a data file, user file, or executable file, or what kind of file is there. Everything is recorded there. Its size, date when it was created, when it was modified, the address in the memory where every, I mean, secondary storage also has addresses. So in which address that file is stored. Now how it has to be accessed. It has to be accessed sequentially, indexed, or direct, or there are several uh, access techniques are there. File manager of the operating system helps to create file, edit the file, copy it, or delete it, or rename it. Lot of operation you can perform using the file manager program of the operating system. So the operating system also take care of that files that are opened with proper access right and all. Means can be file and we can be read or can be deleted or these things. Read only file is there. So all these things are managed using the file manager or the this part of the operating system. So so these are the basic things which are done by the, if you'll see the previous video and this video, so these are the basic things. Process management, once again you just see this, a lot of things are there. Input output management, user interface, multitasking, processor management. So these are the process management techniques. Device management, we have seen this in the previous video also. Memory management, file management. So these are the basic operations which are performed with the help of operating system. Now one more topic I would like to discuss, the difference between 32-bit and 64-bit operating system. Okay, so look at this. You might have seen, or here also, when you'll see your system property, you will find it. What kind of operating system you have. Okay, so we have 64-bit operating. Now, what is the difference between 64-bit and 32-bit operating system? You need to understand this also. So this is the topic. In computing, there is just two type of processors: a 32-bit processor and the 64-bit processor. Now, what is the difference? We'll see this. This type of processor tells us how much memory a processor can have access from CPU register. तो आसान शब्दों में ये हुआ कि ये मोटे तौर पे ये बताता है कि 32 बिट और 64 बिट में अंतर ये है कि वो प्रोसेसर कितना मेमोरी को एक्सेस कर सकता है. How much memory can be accessed using a 32 bit or 64 bit. How it decides? It decides. Look, a 32-bit system can access this much memory only, 2 to the power 32. Now, what is the value of 2 to the power 32? Let us see this. In Excel, things are power function use 2 to the power 32. Okay. So this is the number. Now, what is this? What is the importance of this? This is the number of bytes available in 4 GB of RAM. Yes, 4 GB of RAM contains these many number of bytes. How? Let us see. We have these many bytes in 1 KB, these many bytes, the stupid byte in 1 MB, and these many bytes in 1 GB. And if you'll multiply this 1 GB with a 4 GB, because we have 4 GB of RAM, then you see this comes. So this and this are the same. So this is the number of bytes available in 4 GB of RAM. Yes. So if we have 32-bit processor, then at most only 4 GB of RAM can be accessed. This is the technical and the logical part about the 32-bit. For most of you, it may be a little difficult to understand, but still you need to know this. And for more information, you need to study. Okay. So once again, I would like to show you this. So look at this. What is 32-bit processor? 2 to the power 32. Let us use the power function to once again find it out. 2 to the power 32. This is the value. Now what is this? Look, this is the number of bytes in 1 KB. This is the number of bytes in 1 MB. Now multiply it again with this. Then this is the number of bytes in 1 GB. These many bytes are available in 1 GB of RAM. So if you'll multiply this with 4 GB of RAM, you'll get this number. Okay, so this is 4 GB RAM. So if you have 32-bit processor, then you can hardly access only 4 GB of RAM, not more than that. Okay, even if you have 8 GB of RAM and if you have only 32-bit processor, then only less than 4 GB of RAM can be accessed, not more than that. But if you have 64 bit processor, then see these many number of bytes, or it's an extremely large number. What is that number? Let us see this here. Although Excel cannot represent it, since it is a large number, it is representing in the scientific notation. Let us see this in this. So a 64-bit system can access these many memory addresses, and which is actually 18 quintillion bytes of RAM. In short, any amount of memory greater than 4 GB can be easily handled by it. If you want to use more than 4 GB of RAM in your system, why do we need more RAM? If you want to work with heavy programs, if you want to work more multitasking works, then you need more RAM, obviously. So, and then you need to have the 64-bit processor. So most computer made in 1990s and early 2000, early this during this time, those were mostly 32-bit machines. Okay, the CPU register stores memory address, which is how the processor address data. So you know all these things. So address is accessed from and all. So a 32-bit system can address maximum 4 GB of RAM, which is this much, which we just seen, and the actual limit is less than 3.5 GB, since part of register used to store other values also. So if you have 32-bit of processor, then only hardly this much, only 3.5 GB of RAM can be accessed. This is a technical point. A 64-bit register can theoretically reference these many bytes or itna GB of RAM. Okay, this is too much, too much. I mean, you cannot even think of this. Okay, 16 exabyte of, it's not about 16 GB, it's about 16 exabyte. If you have 64-bit of processor, so this much large RAM is not yet, do not exist right now. Okay, so you may find over the internet what is the current size of RAM, maximum, the largest size. You can find it here because they keep on changing. This is the several million more than the average workstation and all. Another major difference between the 32-bit and 64-bit, the number of calculations per second they can complete. Okay, a 64-bit processor can come in dual core, quad core, 6 core, 8 core version for home computing. Means these are the cores, number of CPUs in one processor. Can be quad core, can be dual. Dual means 2 cores are there, quad means 4 cores are there, 6 cores are there, and 8 cores are octa core you have heard. Hexa cores are also there. Even more cores are nowadays available. Multiple core allows for increased number of calculations per second that can be performed. If you have more number of cores, then more number of calculations can be simultaneously done, which can increase the processing power and help make a computer run faster. Software programs that require many calculations to function smoothly can operate faster and more efficient on multi-core 64-bit processor. So these are the things about the 32-bit and 64-bit processor. More things are there. You can just read them and you can run. So using 64-bit, one can do a lot of multitasking. You can play heavy games with high graphics and all. A lot of heavy programs can be. So thank you, dear students. You have learned today. And if you have not understood, then please watch the video and you can read the articles available over the internet to boost your knowledge level. So thank you. See you in the next class.